Hello. In this episode of kubetuesday, I'd like to show a few things that I had running in the background behind me in the little video of the naming of pods last week. So let's take a look at the resources that are running in that naming namespace in my cluster. And here there is a single pod. I could scale this out to have more, but right now there's a single pod in this and single container in that one pod. Then there is a service, which I'm going to ignore because I haven't really talked with you about services in these kubetuesday episodes so far, believe it or not. We'll get to that at some point maybe if you're interested. Let me know. And here is a deployment. The deployment has created a replica set. The replica set has created the pod. I would have said pods plural, but there's only one at the moment. So I had just called this deployment the naming of pods with hyphens between those words. So I'm just going to define a shell variable with that name explicitly here. Just start off with that kind of hard-coded. Then take a look at the YAML definition of this deployment right here. All right, so just do another the kubectl get deploy of that one deployment in that particular namespace naming. I put it as YAML, and then just pipe to more. So let's actually maximize this right here, and then get a little bit more latitude here. So up at the top is the API version and kind, and then the metadata right here, which is the focus of this song, The Naming of Pods. The specification in the spec down here, and then further down, the status of the currently running or deployed deployment. There certainly might be of interest, but just not right at the moment. Let's focus on that metadata up there. There are a couple of kind of key value pairs. I call them little, tables of information. And there's the annotations listed in here, and then the labels. And these are generated by Helm because that's the way I deployed this little app. So just did a Helm upgrade, double hyphen install probably when I deployed that, or just a Helm install would be sufficient. So these were automatically generated as a part of that Helm chart deployment into this namespace of this cluster. So those are essentially like names in a sense. There is a creation timestamp in here. There is also a generation value of 1 there. But what the song really focuses on, that naming of pods is a curious matter, right? Is the name of the object in general, just to not just talk about a pod or a replica set or a service or deployment, or a horizontal pod autoscaler, any kind of resource, config map, secrets, anything, has a name. And then, although not assigned in the initial Helm chart or Kubernetes manifest, the YAML that we use to deploy these components, we might not have specified the namespace explicitly there, but instead on the command like kubectl apply or kubectl apply, if you pronounce it that way, kubectl by any other name, or if you did a Helm install or upgrade. So there we specify the namespace naming explicitly. Now, that little bit of hierarchy, it's not a massive hierarchy that we have, is within the cluster level. You have your namespaces, and those are like folders in a file system, but logically across multiple servers, across cluster, across the control plane and the data plane of Kubernetes cluster. And so within a given cluster, you're going to have namespaces, kind of subdividing that logically. And then within the namespaces, then we have the different objects in there with their own names. And this particular deployment is a kind of object that we have. And the name of it is just naming hyphen of hyphen pods right there. So the name and the namespace. So there's a little bit of hierarchy here within the cluster. There's a namespace and then the object. And this is just a kind of my notating that this object here is a deployment. I could have just instead called that, instead of an object, I could have called that a deployment. I could have called another object over there the replicaset. Could have called another object over there if I get out of the way here, a po or pod there, and a service, right, and so on. So there's really just within the cluster, there's these two levels. There's the namespace, and then there's the objects like the pods, the replicasets, the deployments, and so on, other kinds of objects. That's it. That's really the hierarchy. There also happens to be a universally unique ID or global unique ID, 128-bit number written in hexadecimal in this customary format. And that UID is another kind of unique identifier in here. So that's really the gist, besides that resource version I ignored there, of what we have here. But let's take a look at something else. I'm just going to hit Q, cancel out of that more that I was going through and viewing that information. Pop back up here, and here I'm going to snag a replica set, which has that naming of pods as the app.kubernetes.io/name label. So I'm going to search for a label here. And so just run this little command here. Let me get out of the way there. Fills the whole width there. So now let's just echo that just to be sure. So that's that replica set name that had come up earlier. Let me go back a few commands here when I'd done the get all right at the beginning of this demonstration. So in here, there is the actual replica set that is specified at the bottom of this output right there. But rather than trying to remember this name, I instead just kind of queried for this by looking for the labels that it uses. Once again, that command that I just now ran, let's do it one more time for fun, is this right here. So I'm looking for app.kubernetes.io/name as a label here with a value of naming -of-pods. All right, so looking for that deployment name, but in the labels, so I can look up what is this replica set name. Because when we go and do canary, blue, green, red, black kind of upgrades, transitions from a new version of the deployment, when it has a different template hash. So I've changed the template of what we want to deploy. Then the replica set doesn't just scale in place. We'll have another new additional replica set for the new version of the app that we've upgraded to. Okay, that's a whole other topic. I don't want to get too much into it, but this has a unique little name, little hexadecimal code at the end of that name. So part of the naming of objects beyond the pods is in this. So that replica set name, again, we just yanked out of there, just doing a query. Okay, cool. But then what if we were to ask, hey, kubectl, whoops, sorry, for my scrolling, the lateral scrolling up in the editor up there. So let's do a get of the replica set. Again, let's focus here down here on the details of a little more vertical latitude there. There we go. So we do have the spec starting to appear right at the bottom. And if there's any status down below that on how the replica set's been scaled in, it'll be showed lower. But this is all metadata. Whoa, that's a lot of metadata in there. Again, universally unique ID there, resource version, and then we have also the name and namespace kind of in the middle at the heart of this little generation creation timestamp. Beyond that, there's three interesting things here. Not just the two we had in the deployment. There is this annotations again, and then there's the labels. And again, this is what I queried for. This name right here is what I queried for, naming -of-pods there, to look up and get and fetch with that earlier command this name of this replica set. And I just picked the first one of those, or the only one of those in this case. So I kind of cheated. If I cared about which one is the newest, I could have sorted by creation timestamp and looked for the newest one. The current one that's being used by the deployment, it's a way to check that as well. But in this case, single version of the app, so I don't have multiple replica sets for it yet. So besides the labels and the annotations, we have this other piece of information down here, the owner references. And the owner references is app/v1 in the API version. The kind is a deployment. So in this sense, what is being indicated here is a different management hierarchy, not the storage hierarchy, the naming hierarchy, which is just cluster, namespace, and then name of an object. That's the storage or kind of naming hierarchy that we have in Kubernetes. But this control hierarchy is different, kind of another dimension, if we will, kind of how the deployment owns and is managing the replica set. We'll see this kind of thing again in just a moment. So the block owner deletion listed as true here, the name of that deployment listed here, and then the universal unique ID for that. This UID at the bottom is of the replica set. This whole block here of owner references is to the deployment that this is referring to right here, right? So these relationships also between the objects. So it's not just the naming of pods and replica sets and deployments, there's also the relationships between them as identified here in this owner references. So it's not just all labels and annotations. This metadata holds quite a lot of valuable, useful information in the operations of how the objects in your cluster are related to one another. Let's quit out of this output here. I don't need to see the spec listed here, but go back to our little view here, and there is another command that I wanted to get here, and then paste that in down behind me there. And so in this case, I wanted to look for a pod that is in that namespace naming, and then has that naming of pods label as the app.kubernetes.io/name, and then yank out of there, out of the list of pods that we might get back. There's only one necessarily, but I'm going to pull the first one of those with square bracket 0, grab its metadata, and grab its name out of the metadata. So we're looking for a pod name. So here, that just happens to be that pod right there. And I only have one, so easy case. If there were 5 or 6 or 20 or more pods, then certainly I'm just picking out the sub square bracket 0, so I'm just getting the first one there. So this particular pod now, we could go and snag the details of that. Let's just go in here, look at that here. And we see a little bit of the spec at the bottom there, and then there's this, the status would be below that. So what did we configure? What do we currently have? Those two pieces there. The spec continues down below here, and then the status would be after that, just alphabetically. But again, here, let's focus on this beautiful metadata right in here. Now, in here, we again have the creation timestamp and the labels, and then the I don't see annotations listed specifically in here in this case. Again, resource version, UID, those kinds of components. The namespace and the name, the heart of this, right again in the middle. Once again, though, the way that the replica set identified that its parent that owns it, controls it, is the deployment. We have the pod, or all the pods, if I had multiple pods that had scaled this replica set out to, would each list that replica set as an owner. So again, this different kind of hierarchy, which isn't the storage identifying hierarchy of objects in namespaces, because these objects are all in the same namespace. The deployment, any of its replicas, any of their pods, all in the same namespace. But there's this owner hierarchy here, all right? So that's identified by this owner references here, which says of this particular pod we're looking at, that replica set right there, called that with that UID, owns this pod. So from the pod perspective, we know who owns it. From the replica set perspective, we know the deployment which owns that within this namespace. All right. Another thing that I pointed out in the song, if you remember, I had noted that we can add generate name. So what's been inserted in here is the what I've called the this value in here. Notice has this part of generate name field, which is used as a part of the prefix right here. Now, notice there's a label that was added here as well, which is called the pod template hash. What is the pod template hash? I have containers here in this pod. Let's go back to the replicaset. Back to the replicaset for a moment. So I'm going to go back to this previous command right here, get the replicaset here, and notice in here, there is the metadata. Now let's continue on here in the replicaset. From the deployment, inherited from the deployment, was a part of this trio here, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q. What are the next three letters of the alphabet in English? We have R, S, and T. R for the replicas up there. The selector is this part right in here, the match labels bit there. And then we have also the template. Notice the size of this thing. This, and continuing on down past the bottom there, is the template inherited from the deployment into this replica set. So workloads, so stateful sets, daemon sets, and this deployment and replica set combination here, for example, these have this pod template of what the replica set is going to deploy out. So notice in there, this pod template has the metadata for the pod that we want to assign. And notice this is added in a pod template hash there for the metadata. And then in the spec, here are the containers that we want. So this is from the deployment through this replica set here. This is what we want to define into the pod. So that's the definition of pod we generated in this case from Helm there. Then there's the status down at the bottom. So that whole pod template, we get a hash code for, and that little code rendered in hexadecimal in there. We can then identify here within the pod, it's copied in when the pod gets created from that template. We have that label right there. That label, where we have this, whatever this value is, 679 Delta Charlie Delta right there, and then 5 Delta 77. Just again, what happened to be that hash value here. That identifies this particular version of this app that was configured in the deployment, got copied into the replica set, and then we have just the hash code of it here. Well, of course, the spec here, where did that come from? The metadata here, where did that come from? From that template. That's what replicas do, or other workload controllers. They'll create then the pods that implement that replica set or stateful set or daemon set, for example, or job that we run. And then cron jobs create jobs. So we have then here, notice this prefix, generate name, naming of pods hyphen, and that is our pod template hash in the name, and then a hyphen, and then what goes after that? I wonder, how many pods do you have in your replica set? 1, 2, 3, 4, your daemon sets, and certainly stateful sets as well. Well, in this case, in this replica set, we have one pod, but each one of them needs a unique name. That just is this suffix here added after that prefix. So the generate name acts as a prefix for all of the pods. So the pods are all named uniquely, right? So they don't all have the same name. They all have unique names. They have the same labels. They have the same owner there, that replica set identified here in this case, but they are all going to have that unique name. So each pod gets a unique name that's also going to be used inside the pod as the host name value, which is going to be related to some DNSable kind of addressability from a network perspective. So we have a unique pod name generated through the workload controller, in this case a replica set, which in turn in this case was created by the original deployment. All right. So go back, listen to the song from last week, the naming of pods, and this hopefully has been a little bit more useful on identifying what we have behind the scenes as far as the naming of pods. Beyond the storage hierarchy, we have this control hierarchy of, in this case, a deployment with a replicaset with a pod in it. But as those are scaled out, as those have new versions, then that multiplicity and that unique set of relationships is particularly important. Hopefully this was a useful episode of Kubetuesday for you. Until next time, take care.